Hello, I'm Cal Blacksmith and welcome back to my shop. Recently I've been asked to go do a demonstration at a Civil War reenactment, and I have to stay period accurate, or at least presentably so to the period. That means I can't be going in with a gas forge, I can't be going in with things that would not have been in existence at the time. So I need to build a forge that's approximately period correct. That means I'm going to be making it out of wood, and I'm not going to be lining it with metal, and I'm not going to be doing all the things that you see other people doing to make forges. Forges can be made out of anything, from a hole in the ground to the most space-age material. But we're going to use wood, a simple installation of a few inches of dirt in the bottom of the forge, and you will not catch the wood on fire. So I went to the lumber yard and I picked up some random bits and I designed it on the fly as I went, and I drew it out here behind me. You can use these dimensions if you wish. The thing is, this is up to you, whatever you have laying around. If you can use 2x4s glued together instead of the 4x4 for the leg, and I'll show you how to do that, that's fine. I have woodworking materials and I have woodworking tools, so I'm going to be using those to put this together because it's easier to do when I have the tools. But you can do this with nothing more than a screwdriver, an electric drill, and a handsaw, and you could build yourself a wooden forge. Now I'm going to be using a side draft. That means that the tweer comes in from the side of the forge, not from the bottom. You see everybody building bottom draft forges where the gases come up, or the air comes up through the bottom. That's not the way a forge that's designed to burn wood is designed. A forge using wood is designed to come in from the side. So I don't need the pipes in the bottom and the ash dumps and all of that. A forge that would be used during the Civil War would be able to be knocked down, tear it apart, collapse it for travel, because all this stuff had to fit onto a wagon, in the least amount of weight that you could carry, the smallest space you could put it into, that would be the better. So my forge is going to be designed to be taken apart and stored in a very small space and put together with nothing more than some carriage bolts and some wing nuts. So without much further ado, I'll zoom you in and go over the drawing with you here so you can understand where we're going, and then we'll start cutting some wood. Hello again. In the last segment I said this is going to be a side draft forge. Actually, it's going to be a side blast forge. The blast is the air coming in, the draft is the smoke leaving. A side draft would be a chimney that's next to the fire so that the smoke would go up the chimney. Now the bill of materials is right here, and the rest of the drawing is behind. This is going to be a wood project. It is screwed and glued together with regular white wood glue, nothing fancy involved. The end pieces are going to be permanent, and the side pieces will be removable, as will the floor. And so all we have to do is drill a hole in one of the end pieces to attach our tweer. Now, in a later video, I'm going to be making a water-cooled tweer, but you don't have to go through all that. You can just use a single piece of black iron pipe and continue to move it into the fire area while you're using the forge. The pipe will be consumed, but that's okay. It's inexpensive, and if you can't go through all the trouble or the expense of making a water-cooled tweer, which is permanent as opposed to a consumable, that's perfectly fine too. Now we're going to go through the wood callouts. These are pieces of nominal dimensions. The actual dimensions that they're cut are different than what you're called out. So a 2x4 is not really 2 inches by 4 inches, it's actually smaller. So the callouts for the wood pieces are actually the lumber store sizes, and the drawing is converting that into what the inches actually are. So here we go. We're going to need four 4x4s, each one 36 inches long. We're going to need two 2x10s at 24 inches long, two 2x10s at 34 inches long, five 2x6s at 24 inches long, and we're going to alter those later. We're going to need two 1x2s by 24, and those are going to be altered later. We're going to need a bottle of wood glue, and we're going to need a box of number 10 by 3-inch construction screws. These are not drywall screws, these are harder screws, they're not deck screws, they're made for actual construction. You can find those in your big box stores. Now the side panel, the leg is 36 inches long, and the 2x10 is actually notched, screwed and glued into the leg. That's going to look like this. The leg stands and the end piece is cut into the 4x4. That means that when this is glued and screwed together to the 4x4s, you're going to get a very strong joint because the whole bottom edge is contacting and resisting movement. So the end piece here is going to be like this. You're 34 inches across. Each 4x4 is going to go like that. So we're going to need to make two of the end pieces. Now the side pieces are 1.5 inches because that's what a 2x is. What works up to 1.5 inches. And then to the bottom we're going to glue and screw a 1x3/4 strip, and that's what the floor is going to sit on. So that's a 1x3/4 strip that's glued and screwed into the side. This is kind of an overall picture of the forge as it's going to be. We've got one end piece here, that's a 4x4 or 4x4, the 2x10 down the side. This is looking straight down. We have the other 4x4, 4x4, 2x10, so they face each other. Now that's going to give us, on the inside, we're going to put the side piece. The side piece, I just shortened it so that I could get the drawing on here. It's 24 inches long. It's your 9.25 inches high because that's what the actual dimension is. We're going to need two of these with the 1 inch high, 3/4 inch thick piece screwed to the bottom. Now, those are going to fit tight so that the 2x10 butts up against this 2x10 and butts up against the 4x4. That's going to give us a very tight joint where the 4x4 is braced into the 2x10. That was a hammer. So we'll do that. The blow up of this moved over here. We're also going to have the 2x6s cut to 4 3/4 because that makes it nice and easy. Five pieces on the bottom. You can use whatever you've got. Those just sit down on these rails here, so that bottom just sits right down flat across there. That's again going to give us a 24 inch on the inside by 24 inch on the inside firebox. And the outside dimensions are obviously going to be a little bit bigger than that. So let's get started cutting some wood. I'm using this. If you want to modify it for whatever you can find laying around in your garage, if you want to cut up pallets, that's fine. That's, make it to your own size, just adjust the dimensions accordingly. Okay, anytime you do any kind of work in your shop, you need to use appropriate safety gear. Appropriate safety gear is at least safety glasses and a good light source. You need to see what you're doing. What I've got here is the 4x4. I'm going to cut this into my 2 legs. This is an 8-foot. I'm going to only get 2 legs out of this 8-foot bar, or I'm used to talking metal, this 8-foot piece of wood. So I will make the other 2 legs out of the 2x4s as I promised you. Now I've got it sitting on what's called a sled. This will make sure that I keep my material square to the blade, square to the table, and I've got a stop arranged over on the corner here so that I can bump up exactly at my 3 feet. The bar, the wood itself is too thick to fit through the saw blade, so I've got the saw blade set at 2 inches, and I'm going to have to roll the wood one time 180 degrees so that I can cut both sides of it. So I'll go turn this saw runs on 3-phase, so I'm going to go turn the power on, and we'll come back and we'll cut a couple of legs, and you'll see how that works. I've turned my 3-phase on, and let's get to work here. I'm going to push down on the wood, make sure that it's nice and flat. I'm going to push it into my stop, make sure that my stop is working. And I'm going to pull forward now. As I pull forward, that takes it off of the stop. That means that I don't have any way for this wood to bind. I can repeat the dimension, but there's nothing going to bind, and that's very important when working with a table saw. So I'm going to turn this on and we'll make the cuts. When your saw is active, never reach across it. Always let it come to a full stop. I've got loose pieces here. I don't want to take a chance of something throwing me into the saw or throwing wood into the saw and having an accident. So I'll pull this leg off. Always remember to hold on to your pieces and rebalance everything. On the other hand, I do have a very nice cut, and there you go. You can see that the two cuts matched up perfect. And let me pick everything up and we'll get ready for the other cut. Okay, we're set up to do the other leg. Hey, I'm not used to making videos at the same time. My attention was split and I forgot to retract the sled to keep things balanced. So let that be a lesson. Always remember what you're doing regardless of what's going on around you. Alright, so this is the second leg I'm going to make, and it's butted up against my stop gently so that I don't move the stop. Move it forward off the stop, hold it, turn the saw back on. Alright, I remembered that time. So line these up. Here's my two legs. What a beautiful match it is. There can't be more than a couple of thousandths difference in the length. You don't have to use a table saw. You can use a circular saw, you can use a hand saw. I suppose if you could train a beaver, you could use a beaver to cut the wood. I happen to have the tools, so I use them. It makes my life a little bit easier. Okay, what I've done is taken you off the tripod, and you can see here that what I have to notch the 4x4 for the 2x10 to fit. So what I've done is I've put a piece of waste material here against the fence. Then I've set the fence so that it cuts the perfect depth from the inside of this tooth to the inside surface of this stop block to clear for my 2x10 so that it can set back in. What I need to do now is set the blade height to the same thickness as the 2x10 is, and then when I run the 4x4 across the blade, it will clear the stop block, which means that it cannot bind. There's nothing to bind on. As long as I'm holding it solid across the compound slide, then everything's fine. And you run straight on through, and then that will cut the bottom of the slot. And then you can either take a lot of cuts, one after the other, and work it out, put a dado head in and cut it out, or you can put it on a router table or use a router and cut that out. But the thing is, what we need to do is we need to, let me grab a pencil here, we need to cut a piece here, cut the thickness down of our 2x10, and then take that out all the way across so that the 2x10 will fit flat in that notch. And when it's screwed and glued, then the end of the 2x10 resting on this shoulder will then make a solid joint for the end pieces of the table. So I'm going to put you back on the tripod and you can watch that process. Okay, I need to set the height of my blade to exactly that of what the thickness of my 2x12 is. What I have here is a scrap piece of wood that came off it, one of my cleaning up cuts, so I know exactly the thickness that I need to account for. I'll set that next to the blade and adjust the blade up and down until the teeth just clear it. Alright, there it is. Now what I'm going to do is I'll just make sure that I'm butted up solid against my stop, like that. The stop is giving me the exact distance to this side of the blade. And I'm going to proceed to cut through, and then that cut is going to mark the bottom of the notch that I'm putting in my 4x4. I can either proceed to do a lot of cuts across, I can space the cuts out across and use a chisel to clean it up. I can put a dado head in, I can cut it up with a dado blade, I can put it on a router table to cut that out. You can even take and cut up the side with a bandsaw. So there's a lot of ways that you can remove that waste, and all we're doing is just making a place for the 2x10 to sit into the corner post. Alright, I've got to take my safety off and try that again. Okay, that only took a second to release the safety and to remove it. It just fits in really nice. Just real quick turn of a single hand nut and the safety's out. That keeps the wood split, so in case the wood wants to bend over, it won't jam the wood into the blade, creating a safety hazard. So I butt up against my stock, stop, turn the saw on, and we'll finish that cut. And there you go. That's the first cut. That's the depth. That's the depth that we've got to notch out. That's same all the way across. And then that's going to allow our 2x10 to sit flat in that corner, and we can screw it in and make a nice tight joint. We'll do that to the other one, and then we'll clear this out. Okay, I've decided to go ahead and install the dado head, and you can see that that will cut a much bigger swath through the wood than the standard blade. Standard blade's 1/8 of an inch, and the dado head that I have set up here, let me tape out, that will cut about 7/8 of an inch out of cut. So that's going to make the job go much faster. Let me set the camera up on the other side so you can get a better shot of this, and we'll continue to cut this board. I have the stop reset so that the first pass will clear inside my initial cut. Therefore, I will leave my original shoulder that I cut there intact, and then we'll just go ahead and continue to clear out all of the unneeded wood. Alright, drop the blade down out of the way. So I've got the table. I'll roll this back down. My stop here is made off of a cut-off scrap, but you'll see that the cut is very nice. The 2x10 is going to sit in there very, very nicely. There we go. That's going to get glued and screwed and cleaned up a little bit, and that'll make a very, very tight joint.